All right, so here's the solutions starting at number 10 for the Trig exam prep packet. So a ship sailing parallel to the shore sights a lighthouse at an angle of 12 degrees from its direction of travel. After traveling 3 more miles, the angle is now 20. At that time, how far is the ship from the lighthouse? So I'm going to draw the shore. We have a boat, and we have a lighthouse that's on the shore. I'm trying to do a better job drawing the boat, kind of a top view of the boat. Anyways, the angle that is first met is the angle 12 degrees. Then it travels further and now the angle is 20. Man, that's hard to see. So let me reorientate this triangle. So it's 12 and then 20. So if I reorientated this, you would have 12 degrees, and then you would have 20 degrees. And then the question is, how far is the boat from the lighthouse? So this is the distance I'm trying to find. The distance the boat is from there. Now what do we know? We know this distance here is 3 miles, and we know these angles. So to solve for x, I need to use one of the laws of trigonometry that I know. We're going to use the law of sines. So I know one side. I need to know the angle up here opposite of that. So using some triangle properties, you can actually subtract these. 20 take away 12, and know that that angle up in that corner is 8 degrees. So we have sine 8 over 3 miles is equal to, now the angle opposite of x is 12, so it would be sine 12 over x, and then you'd cross multiply and divide and use your calculator. So I'm going to do that. That's it. So 3 times sine 12 divided by sine 8. And then if I rounded it, it'd be about 4.5 miles. Number 11. A surveyor is standing 57 meters from the base of a building. The angle to the top of the building and finds it to be 35 degrees. Then measuring the angle to the top of the radio tower that's on top of the building and finds that angle to be 46, how tall is the tower on top of the building? So let's see if we can draw this situation. So here I have a surveyor, and on there he's surveying a building, and on top of that building is a tower, a radio tower. My goal is to find the height of that tower on top of the building. What I know is when he measured to the top of the building, the angle was 35 degrees. We also know the distance that the surveyor is from the base is 57 meters. He then measured again and measured to the top of the radio tower. And that whole angle, the whole angle there, is 46. And my goal is to find this height. So what I'm going to do is I'm going to break it down into 2 triangles. So one triangle is going to have 35 degrees. I'm going to call the missing side I need x. That's going to give me the height of the building. Then the next triangle, that angle for that is 46 degrees. I'm going to call that y. That's to the height of the radio tower from the ground all the way top. Then my goal is to find the height of the radio tower. I'm going to take the value for y and the value for x. I'm going to subtract them, and that will give me the height of the tower on top of the building. So this is, you could use law of sines. I'm going to use right triangle trigonometry. 35 degrees, opposite and adjacent, that's tangent. So the tangent of 35 is equal to x over 57. So to get x by itself, I'm going to multiply by 57. And I get 39.9 meters. That's the height of the building. Now, to find y, it's exactly the same setup. The only difference with y is it's not 35 degrees, it's 46 degrees. So the exact same setup. Use your calculator, just change 35 to 46. And to the top of the radio tower, I get 59.0 or 59 meters. Now, what do I do to find the height of the tower? Is I subtract these numbers. So 59 take away 39.9. And the height of the tower then when you subtract it is 19.1 meters. Number 12. Two surveyors are 180 meters apart on the same side of the river. Measure their angles to a point between them on the other side of the river to be 54 and 68 degrees. How far is the point? How far from the point is each surveyor? And round your answer. So I have a river. On that river, I have two surveyors. Call one A and one B. They're on the same side of the river. And then they notice a point in between them, and then they measure the angle it is to get there. So one angle is 54. The other angle is 68. The order doesn't matter here, because you're just looking for the two numbers. So I'm going to call one x, and I'm going to call the other one y. And then I'm going to find both distances to that point. So the distance they're apart is 180 meters. So I know from A to B is 180. To solve this, x and y, I need to know what law to use. So because it's angle, side angle, or because I can find the angle opposite of 180, it's going to be the law of sines. So my first step is, can I go 180, subtract 54, subtract 68? So that angle up here is 58 degrees. Next, I'm going to go sine 58 over 180. And then to solve for x, I need the angle 68. So to get x by itself, I'm going to multiply 180 times sine 68. Then I'm going to divide by sine 58. And so one distance is 196.8, and that's in meters. Now, to solve for y, I just need to change that angle to 54. So it's already in my calculator. So just change 68 to 54, and you get 171.71 or just 7. So those are the two distances they are from the point. Here, I'll write it out over here. Again, it's sine 58 over 180. And then for y, you would use 54. All right, 13. Can you solve this triangle? It is a side angle side triangle. So first step is I need to solve for b using the law of cosines. The law of cosines starts with a big square root sign. And then I take one of the sides and I square it. Take the other side, plus, square it, subtract 2, multiply those two sides, and then the cosine of the angle in between them. And then use my calculator. So I'm going to go square root 3 squared plus 9 squared, subtract 2 times 3 times 9 times the cosine of 50. And the approximate answer is 7.4. I'll leave it at that. Next, I need to find these angles. So if I want to find angle C, it's the inverse cosine. And I start with the side opposite, which is 9, and I square it. Then I subtract, and I pick another side and square it. Subtract, pick the last side, and square it. And then the denominator starts with -2, and you multiply it times the same last two sides, and then use your calculator. Now, remember, when you go inverse cosine, we need to start with 2 parentheses here, and then type in 9 squared, subtract 3 squared, subtract 7.4 squared. Then close the parentheses, divide, then open the parentheses, and then -2 times 3 times 7.4, and then close it twice, 2 parentheses at the end. Diamond enter, and the angle is about 112.8. Now, to find angle A, because I already know 2 of the angles, I can just go 180, take away 50, take away 112.8. And that gives me 17.2. All right, turn the page. Again, could you solve this triangle? So we're finding the missing angles, side, 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 using the law of cosines. So I'll start with A, just because. You could start with any of the angles. What side is opposite of A? So we start there. And then I subtract. Then pick another side, square it, subtract. Pick the last side and square it. The denominator is -2, and then 7 and 4. And now use your calculator. So we're going to go inverse cosine, start with 2 parentheses, 6 squared, subtract 7 squared, subtract 4 squared, close the parentheses, divided, open the parentheses. -2 times 7 times 4, close it twice, diamond enter. What did I type? Oh, I typed it on 4. And I get the angle 58.8 degrees. Now, I need to do the work again for B. So, I'm going to set it up. To find B, opposite of B is 4. So I start with 4 squared. Then subtract and pick another side. Subtract, pick the other side. -2, and then 6 and 7. So follow the pattern. And now type it in. and I get 34.8 if I round it. Now angle C. Now that I know two angles, I can just go 180 take away and use your calculator. And I get 86.4. Number 15. Two sailboats leave a harbor in Bahamas at the same time. The first sails at 21 miles per hour in a direction of 320 degrees. The second sails at 33 miles per hour and its direction is 210. Assuming that both boats maintain the same speed that they have and heading, after 5 hours, how far apart are the boats? So what we're going to do is, I'm going to draw a set of axes. And what I'm going to do is, I'm going to say the origin is the harbor where they both started at. So the angle 320 is in quadrant number 4. And the angle 210 is in quadrant number 3. So I'm going to draw the boats in what direction they're going. Then I'm going to connect the ends together and recognize that's what I'm looking for. That's my goal. So let's fill in some numbers that we can fill in. So the first boat is going 21 miles per hour. So if you're going 21 miles per hour and you've gone 5 hours, then altogether what distance have you gone? So the first boat has gone 105 miles. The second boat, using the same formula, is going 33 miles per hour. Same thing, going for 5 hours. So multiply them together, and you can see the distance the second boat has gone. So already I have two numbers here. The last thing I need to know is understanding what the angle is inside the triangle. So I need to know the reference angles, and that will help me out. So for 320, if I go 360 subtract 320, the reference angle is 40. That's this angle on the outside. If I go 180 subtract 210, put 210 on top, the other reference angle here is 30 degrees. And then understand that all three angles make 180. So if I go 180, take away 40, take away 30, what I'm left with is the angle inside the triangle, which is 110 degrees. Now I can use the law of sines to know how far apart they are. So for the law of sines, it's a big square root. Start with the side and square it, plus the other side and square it. Subtract 2, then multiply the two sides together, and then it's the cosine of the angle in between them, which is 110. All right, now use your calculator. And you find that the distance between them is about 224 miles if you round. All right, one more story here. 2 points A and B are on opposite sides of a building. A surveyor selects a third point C to place a transit. So we have A, we have B, and then there's a third point C. We know that point C is 46 feet from point A. So I'm going to label that 46 feet. And 68 feet from point B. So C is that far apart. Angle ACB is 54 degrees. And then the question is, how far is A to B? And I'm going to label that X. Oh, then do it up here. There you go. So A to B to C, and then label what I said. Now, to find x using the law of cosines, 46 squared plus 68 squared minus 2, 46 times 68, and then it ends with the cosine of 54. I'm going to type it in. And the distance there is 55.34, so I'll just call it 3 feet. All right, number 17. How do you find the area of a triangle when you know all 3 sides? This is called Heron's formula. So step 1 is to find what's called S in the formula, which means we're going to add all 3 sides together, take that answer, and divide it by 2. So this is 19 divided by 2, which I know is 9.5. Next, to find the area, it's a big square root. And we start with 9.5. And then we go 9.5 and subtract each side 1 at a time. And then type it in your calculator, and you found the area. And the area is approximately 14.98. And if I round it, oh, they said 2 decimal places, so 14.98, and there's no units to square. Number 18. Can you find the area of a triangle when it's side, angle, side? So this one's the trig formula. And the trig formula is 1/2 times 5 times 8 times the sine of the angle in between them. And that's it. So 0.5 times 8 times 5 times the sine of the angle in between them. And the area is 19.32 if you round it. All right, turn the page. A painter needs to cover a triangular region, 62 by 66 by 75. A can of paint covers 70 square meters. How many cans will be needed? So step 1 is to find the area. So it's side, side, side. So I know I need to go 62 plus 66 plus 75 divided by 2. There's the start. And then the area. So big square root sign, 101.5. Take away 62. 101.5 take away 66. 101.5 take away 75. And then get the area. So let me do that. And you get 1,942 as the area. Now, we need to understand the second part. So each can covers 70 square meters. So I take the area divided by 70. And then I have to round up. So how many cans do I need? So if I round up, I need 28 cans to cover that room. All right, number 20. A room in the shape of a triangle has 3 lengths to it. Carpeting costs $16.50 a square yard, and the padding is $5.25 a square yard. How much to the nearest dollar will it cost to carpet the room? So step 1 is to find the area. So 7 plus 10 plus 15 divided by 2. So that is 25, 32 divided by 2, that's 16. Then the area is the square root of 16, 16 take away 7, 16 take away 10, 16 take away 15. And order doesn't matter when you do that. So you just have to subtract one side at a time. So let me get the square root. 16, 16 take away 7, 16 take away 10, 16 take away 15. So I get an approximate area of like 23.39. I'm going to just keep the number in my calculator. What I know for the cost is each square foot costs $16.50 for the carpet plus the padding that goes underneath it, which is $5.25. So I have to add those two numbers up and then multiply it times your area to get the total cost. So I'm going to multiply it by $16.50 plus $5.25. And then the total cost would be about $639.32 to carpet it. All right, so that's up to question number 20. I'm trying to break this review up into little chunks. So that's up to question number 20. Mr. G Math, over out. The next one will start at 21.